Hello, and welcome to Zach, Vincent, and Anisha's Copper Amine Synthesis and Spectrophotometric Analysis Lab video. Before we start today's video, we first need to discuss what exactly we are doing in today's lab. We're going to split this up into 4 steps. First, we're going to perform our serial dilutions. Second, we're going to transfer our solutions into tiny containers called cuvettes. Then, we're going to move all of our cuvettes to the spectrophotometer room to collect data with the spectrophotometer. And then lastly, we're going to take the data which we collect and do a little bit of math. With that said, let's get started. After you've completed all of your dilutions, you should have a total of 3 dilutions, a stock solution, and simply water. We're going to transfer all 5 of these substances into their own individual cuvettes. Take note that on the cuvette there is a very tiny line. You want to fill up to it as close as you possibly can. Don't go over it, as we don't want to overfill the cuvettes and risk spilling. Now let's run on to the spec room. Okay, so we need to first find our lambda max. Lambda max can be defined as the wavelength at which a substance has its strongest photon absorption. What this means in simple terms is that it is the wavelength of light that is being absorbed the best. Take note that our lambda max is found after we scan across all wavelengths of light in the spectrophotometer. Scanning across all wavelengths is what allows us to find that lambda max, or rather, the wavelength of light that we really need to focus on for the rest of the spec lab. So we're going to need to zero out our spec. So to do that, we're going to take our water that's in one of the cuvettes, and you're going to see here a little triangle right here. This is going to be the side that is going to be facing the light. So we need to make sure to clean that off with a chem wipe that's found in the lab. Get it nice and clean so there's no fingerprints on it. We're going to take it to the spec. Place it in there with the arrow again facing the way of the light. We're going to close our spec, come over to the computer, and we're going to press 0. Press OK. And we have now zeroed out our spec, but now we need to also find the lambda max of our stock solution. Put our water, take our stock solution that we made, and we're going to do the exact same thing. We're going to wipe it down, make it nice and clean. Come over here to the spec. Come back to the computer, but instead of pressing 0 this time, we're going to press start. And as we can see here, we have a 0.254 ABS, and we have a lambda max, which is going to be the highest point on this curve that we can see, about 615 at its highest point, which you will notice down right here, where it is labeled your x-axis is going to be your lambda max, and you're going to place those numbers down into your journal. So we have our absorbance of our stock solution, which again we got from the top left of the screen, and we have our lambda max labeled at 615. Now that we have our lambda max, it's time to open up the Simple Read application on the computer. Since we were opening up a new application on the computer to read absorption rates, we are going to have to zero out the scale one more time to get the rest of our data. On the left of the screen, that is exactly what Vincent is doing. He is zeroing out the scale with a water blank, going up and pressing read. That is going to zero out our scale. Now that we've done that, we can start our dilutions. Here we are going to do the exact same thing we did for the stock solution. We're going to chem wipe everything down, as the dust can really affect the outcome of our data. Dust particles will be scanned if they are present on the cuvette. Once you have found the data, it is time to place that into your book, as we are going to need it for a little bit of math. Try not to worry about the math too much, as most of it is done through Excel. Do take note, however, the relationship between the equation on Excel and that of the Beer-Lambert law, which states that absorbance equals molar absorption times path length times concentration. One should also take note that this means that the relationship we see between concentration and absorbance should be directly proportional, meaning as concentration gets higher, so does absorbance. This is why zeroing out our scale with a blank is so necessary, because not only will we be measuring what we want to measure, which is the copper amine solution, but we will also be measuring all of the water particles involved in the solution as well, which will in fact skew our data, because we don't care about the water. We care about the copper amine solution that we created. This is also the reason for chem wiping our cuvettes down. The particles will in fact get in the way. This is because the spectrophotometer is super sensitive. Anything that we do not want to look for, we do not want to scan, as it will mess up our final solution. With that said, once you're finished, make sure to clean up your lab space, and thank you so much for watching this video.